Hello, class. Today, what we are going to do is we are going to look at angles of triangles. All right, so we're going to look at the triangles, angles, and we're going to start off by just introducing triangles. We're going to start looking at that in this chapter and for most of the rest of the year, actually. We're going to spend a long time talking about triangles. So, just to refresh, remember things that we already know. We can classify triangles by the sides. We can classify triangles by their angles. All right. So when we classify triangles by the sides, what we know are they scalene, isosceles, or equilateral. Where scalene has no congruent sides, isosceles, for important, has at least two congruent sides. So at least two congruent sides. And equilateral triangles have three congruent sides. Now, what this means is technically equilateral triangles are also isosceles because they do have at least two congruent sides. Okay. We can also classify triangles by the angles. Acute triangles, all three angles are acute. Right triangles, they have exactly one right angle, and obtuse triangles have exactly one obtuse angle. And then there's this other one which you may or may not have talked about before. These are equiangular triangles. Just like we have equilateral means all the sides are equal. Equiangular means all the angles are equal. So all three angles are congruent. And the thing about this, keep in mind, just so you know, this means that equiangular triangles are always going to be acute. Also, equiangular triangles will always be equilateral as well. All right. So real quickly, we are going to take a look at this. I'm going to do a couple examples. We want to classify some triangles by their sides. So it gives this triangle OPQ and wants to know, classify it by its sides, and then tell, is this a right triangle or not? Notice they did not tell us how long any of our sides are, so we're going to have to figure that out ourselves. They also did not tell us anything about the angles, so again, we're going to have to figure that out all by ourselves. So we're slightly annoyed, but that's okay. We can do this. So first, we need to know how long are all of these sides, right? So let's just jump right into this. PQ, I can't count any of them because they're all at angles, so I can just count over and count up or anything like that to know how long the sides are. So we're going to have to distance formula. So the distance formula, if you remember, is the square root of x1 minus x2 squared plus y1 minus y2 squared, right? And this is the distance formula. So we just take our points and we plug them in. So if we're going to do segment PQ, then we need, so let's see, the length of PQ equals the square root of, let's see the x's, so -1 minus 6, -1 minus 6 squared plus the y's, 2 and 3, so 2 minus 3, 2 minus 3 squared. And it doesn't matter which one's 0.1 or which one's 0.2. It's just, I did PQ, so we're going to PQ. All right. So let's see here. -1 minus 6 is -7, and -7 squared is going to be 49. Write that down before I forget it. 2 minus 3 is -1. -1 squared is +1, so +1. And so I end up with the square root of 50. And I could simplify this if I want to, but I'm just going to leave it like that because I just want to see, are these the same? Right? I know this one is obviously not the same, but these two, they might be. So square root of 50, you want to see if that comes out to the square root of 50 as well. Now, there is another way to do this. If you don't like the distance formula and you have a graph, other way you can do this is just Pythagorean theorem. Okay, so I'm going to look at segment OQ. Segment OQ. And I'm going to take this on my graph. I'm going to make a right triangle. Right here. Right triangle where segment OQ is the hypotenuse. And so then I have a squared plus b squared equals c squared. So I want the square root of a squared plus b squared. So the square root, a squared is 1, 2, 3. So 3 squared plus b squared, which is going to see from 0 to 6 is 6. All right. So let's see, 3 squared is 9. And 6 squared is 36. So this ends up being the square root of 45. So are these two sides the same? No, they're not. They're close, but not quite. And we could figure out this one. It won't take long, so we might as well. Let's go ahead and do that. So we have segment PO would be the square root of, let's see, we're going over 1 and up 2. So that'll be 1 squared plus 2 squared, which equals the square root of 1 plus 4, which is the square root of 5. So we see they are not the same. None of these are the congruent, and so this is a scalene triangle. So we'll say that, scalene. Scalene. Now, we do need to know, is this a right triangle? Because it asks, is it a right triangle? So what we're going to do, we're going to look at our lines. Which of these lines could possibly form a right angle? And that would be segment PO and segment QO. Those might be a right angle. And to know how to do this, what we're going to look at and see, are they perpendicular? Right? Because perpendicular lines form right angles. So to know if these are perpendicular, what we're going to do is we're going to look at the slope. Okay? Which is another way of doing this with the Pythagorean theorem, kind of helps us out. Because we already know this is 3 over 6, and this one is over 1 up 2. So let's see, the slope of OP, the slope there is going to be up 2 over 1. So 2 over 1, that's 2. Oh, wrong way, going this way. Down 2 over 1, negative 2. Negative 2. And over here, we're going up 3. So this is for segment OQ. OQ. We're going up 3. So up 3. And right 6. And that will simplify as 1/2. And our slopes, negative 2 and positive 1/2, those are opposite reciprocal slopes, which is what we need for have perpendicular lines. Or if you prefer the technical definition, negative 2 times 1/2 equals negative 1. That's the technical definition of perpendicular slopes. But we see that works. And so segment OP is perpendicular to segment OQ, which means this is a right angle. So what we have is a right scalene triangle. Right scalene triangle. So not too bad. What I would like for y'all to do is to pause the video and work out number 2. Same thing, we want to classify the triangle by its sides and then determine whether it is a right triangle or not. This one will be slightly more difficult because we don't have the graph. So we're going to have to do distance formula for all 3 of these, not the Pythagorean theorem. All right. So go ahead and work this out, then come back and check your answer. All right, let's see how we did. First, let's just find the length from A to B. All right, so distance formula, we have 6 minus 9 squared plus 6 minus 3 squared. 6 minus 3 squared. So, and this is for segment AB. 6 minus 9 is negative 3. Negative 3 squared is going to be positive 9. And 6 minus 3 is negative 3 squared, or is positive 3 squared, which is going to be positive 9. So I end up with the square root of 18. All right, let's try BC. BC is going to equal the square root of 9 minus 2. 9 minus 2 is, well, let's write it down. 9 minus 2 squared plus 3 minus 2 squared. 3 minus 2, that's a 2 squared. All right. So 9 minus 2 is 7. 7 squared is 49. And 3 minus 2 is 1. Squared is 1. So this came out to that square root of 50 that we had a minute ago, isn't it? So this is square root of 50. So these two aren't congruent. So we know that's no good. Not going to be equilateral. Now let's try segment CA. CA is equal to the square root of, let's see, we have 6 minus 2 squared plus 6 minus 2 squared. Well, that makes it easy. So 6 minus 2 is 4. 4 squared is 16. And 6 minus 2 is 4. And 4 squared is 16. And so this is the square root of 32. And none of those matched. So this is also going to be scalene. Now we need to see, is this a right triangle? So we need to find the slope for all of these. Well, I don't have a graph anymore, so I have to do the slope formula, which, if you remember, slope is equal to y2 minus y1 over x2 minus x1, or if you prefer, change in y over change in x, right? So first, let's see from A to B. I'm going to do this as change in y over change in x. Change in y over change in x. So from A to B, that is going to be my change in y. So I went from 6 to 3, so that was down 3. From 6 to 9, so that was up 3. This is going to be negative 1. All right. Let's take a look at BC. Segment BC, again, change in y over change in x. So change in y, I went from 3 down to 2, so that's going to be negative 1. And then I went from 9 down to 2, so that's negative 7. And so this is going to be 1/7. All right. No right angle so far. Let's try C. We're going from, let's see, we got from 2 to 6, so that's up 4. And then from 2 to 6, which is up 4. So this is a slope of 1. And here we go. We have those two are opposite reciprocals. So we have that AB is perpendicular to CA, because we have opposite reciprocal slopes. 1 times negative 1 is negative 1. And so we do have a right scalene triangle, just like we had before, which is, I guess it's good. Better if our examples have different kinds of things. So, right, scalene triangle. All right, so that is classifying angles on a coordinate grid. Classifying the sides, and you can't really classify the angles other than if it is a right angle. Okay, it's a little bit more difficult to find if something is acute or if it is obtuse, because just looking at it, it's hard to tell the difference between, say, an 89-degree angle and a 91-degree angle. But you can at least tell whether or not it is a right triangle or if it is or not. So, all right, let's take a look at the rest of this. We have 3 theorems. The triangle sum theorem says that the sum of the measures of the interior angles of a triangle is 180 degrees. So first off, the interior angles, very simply, those are the angles inside the triangle. So these 3 angles here, these are the interior angles of the triangle, and this says that they add up to 180 degrees, which y'all should already know. You've been using that since middle school somewhat. All right. Exterior angle theorem. This one is probably going to be new. What this says is the measure of an exterior angle of the triangle is equal to the sum of the measures of the 2 non-adjacent interior angles. Another way that you might hear this referred to is these are the remote interior angles. Okay, so angle A and angle B are not adjacent to angle 1. So what this says is that angle A plus the measure of angle B equals the measure of angle 1. Okay. And then we have the corollary to the triangle sum theorem. A corollary, what a corollary is, this is just a theorem that can be proven very, very easily from another theorem. And what this says is that the acute angles of a right triangle are complementary. So the measure of angle A plus the measure of angle B equals 90 degrees. And that's because all 3 of them together are 180 degrees from this theorem. And so if this is 90, that means there's only 90 degrees left for these 2. Okay, so not a big deal. So let's open this up. Let's take a look at this. This won't take us very long, hopefully. Let's see here. Number 3, we want to find the value of x. Well, let's see. We have 1, our three angles here, we know that all three of these together are going to add up to 180 degrees. So 85 plus 63 plus x equals 180 degrees because of the triangle sum theorem. So all we have to do is add this up. So 85 and 63, combine my terms here, so that would be 8. And 148 plus x equals 180. And then we're going to subtract the 148 from both sides. 148. And so x equals, let's see, that would be 2, and borrow the 7, the 1. 7 minus 4 is 3. So that ends up with 32 degrees. That's it. Not too bad, right? That's a problem you probably got in 7th, 8th grade. So let's take a look at number 4. Here we are looking for angle 1. Well, what was the name of that one? The exterior angle theorem says that angle 1 equals the sum of the two angles that are not adjacent to it. So angle 1 is going to equal the sum of these two angles. Right? So that means the measure of angle 1 equals 53 plus 53. That's easy enough. That means the measure of angle 1 equals 106 degrees. All there is to it. Okay. And if you think about it, these two angles here are going to be supplementary because we have a linear pair, right? And so if these two are supplementary, that means that this plus that equals 180. And these two together, plus whatever that is equal to 180. So these two have to equal the same, is what that means. How that works. All right, let's see here. Let's do another really simple one. Again, finding the measure of x. Well, we know all three of these equal 180, so we could do 61 plus 90 from 180, but this is a right angle, which means these two, the correlated to triangle sum theorem says those two have to equal 90. They're complementary. So I can just do 61 plus x equals 90. Subtract 61 from both sides. And so x equals, what is that? That is 29 degrees. And that's it. Saves us a step. So, not bad. Okay, what I would like for you to do, pause the video and work out these next two. All right, find the measure of angle 1 and then find the measure of each angle here. All right, so pause the video, then come back and check your work. All right, you're back. Let's see how you did. So we're looking at this. We want the measure of angle 1, which is a little bit more difficult to find. Now, if I knew what this one was, I could just subtract them both from 180, right? But I don't know what that one is. I need to know what x is first. So to get what x is, I've got to put these two together. But I can't just put them together. This is an external angle, so I know that the external angle is equal to the sum of the two remote internal angles, the non-adjacent angles. So I can add those up, and that will equal my 5x minus 10. So 3x minus 40 equals 5x minus 10. All right, so let's see here. First, I'm going to subtract 3x from both sides, so minus 3x, and I'm going to go ahead and move my 10 over there. So plus 10, so that cancels out, and I have negative 30 equals 2x divided by 2, and I end up with x equals negative 15. That does not look right. What did I mess up? Oh, that's a plus. There we go. So this is all wrong. So we get out our good buddy, the whiteout. See if I can get this. All better. So 40 plus 10 is 50. 50 divided by 2 is 25. So x equals 25. So now I can figure out what this angle is. Or I can figure out this one. Either one. I know what, I think I'm going to plug it in here. So 5 times 25 minus 10. 5 times 25 is, well, 5/4 is $1.25. So that's 125 minus 10. So this is going to be 115. And then I know these two are a linear pair, so they're supplementary. So I can do 180 minus 115. And that is going to give me, let's see, that's a 5, and that will be 6. 65 degrees. There it is. Hopefully that's what you got. All right. Let's take a look at these next ones. Find the measure of both of these angles. Well, that's annoying, but that's okay. Now, I could take these, add these together, plus 90 equals 180, but I already know that's 90 degrees angle, so these two are complementary. They add up to 90. So 2x plus x minus 6 is going to equal 90. Combine like terms, I have 3x minus 6 equals 90. Add that 6 to both sides. 3x equals 96. Divide by 3, and x equals, let's see, that would be 32. All right, but I'm not asked for x, I'm asked for these two angles. So 2 times 32 equals 64. So there's my first one. And then I have 32 minus 6, which is 26. And so there are my two angles. All right. Okay, so hopefully this wasn't too bad. Hopefully this helps. Yeah, these three theorems. Only two of these are probably new, and you may even have already heard that one before. So hopefully this wasn't too bad. I hope it helps, and I will see you next time.